All right, so as we look at this first one, what is the temperature at 3,200 meters if it is 8 degrees Celsius at 1,700 meters? So I've got it kind of set up here for you so you can see you're starting at 1,700 meters at the bottom of the mountain. Um, and then you're going to go to 3,200 meters. So that means that you are going to change elevation by 1,500 meters. Okay. Also, what we need to look at is the fact that you are moving up. And so because of that, you are going to use the ELR. And I gave you the ELR as 0.65 degrees Celsius per 100 meters. So we're going to take this 1,500 and we're going to divide by 100, and that's going to give us 15, which we'll then take and multiply by 0.65. And if we multiply that out, we're going to get 9.75. That's how much the temperature will change as we move up. Because we're going up, the temperature will get colder. And so we started at 8 degrees. So we're going to go 8 minus the 9.75, and that's going to give us negative 1.75 degrees Celsius. Okay, so that's the temperature right there. So again, for this one, it's the ELR because you are moving up in the atmosphere. For the next one, two things are going to be a giveaway. This word parcel and then after rising. So anytime you see a parcel of air, it is air that is going to rise. And because the air is rising, we're going to use the DAR. And the DAR is 1 degree Celsius for every 100 meters. The air is going to rise 900 meters. So we're just going to take 900 and divide by 100, and that is 9. The temperature was 16 degrees to start, so we do 16 minus 9 is equal to 7 degrees. And so that's the answer to number 2. So again, this one, the air is rising. In the first one, you move up in the atmosphere. Number 3 is a little bit trickier, so I've drawn it out here, so hopefully it'll make a little bit more sense. So in total, the air is going to rise 4,000 meters. But along the way, at 1,800 meters, a cloud is going to start forming. So it started forming a cloud at 1,800 meters, and it's asking what's the temperature of the top if it was 27 degrees Celsius to start. Okay. So initially, as the air is rising, we are going to use the DAR because it's air rising and it's dry air that's rising. So it rose 1,800 meters. So we're going to take the 1,800 and divide by 100. And the temperature is going to drop 18 degrees on its way up. It started at 27. So 27 minus 18 is 9 degrees Celsius. So at this point right here, it is 9 degrees Celsius. Okay. But the air is going to continue to rise. And as it does, it started forming this cloud, which means condensation is taking place. And because condensation is a warming process, the rate at which the air is going to cool off slows down. So it's still air that's rising, but now it's in a cloud, it's moist air. And so it's going to go down at 0.6 degrees for every 100 meters. Okay. Between 1,800 and 4,000, that's 2,200 meters that the air will continue to rise. So I take that 2,200 and I divide by 100, which gives me 22. And then I multiply that by the 0.6. And if I do that, I'm going to get 13.2. Okay. The temperature was 9 degrees at the bottom of the cloud. It went down another 13.2. So 9 minus 13.2 is equal to negative 4.2 degrees Celsius. Okay. So that is here at the top of the cloud. All right. And then for the last one, the temperature of the air is 18 degrees Celsius. A parcel of air is heated to 23 degrees Celsius, and its dew point is 5 degrees Celsius. So it's asking what level clouds will form at, if at all. And so what you need to understand is the parcel of air is the one that really matters because that's going to determine how high the air will rise And when it rises, it's expanding, cooling off, and getting more humid until it reaches its dew point. So we're really going to compare the parcel of air to both the surrounding air and to its dew point. Okay, so on this side over here, we're going to look at how high the clouds will rise. And in order to do that, we look at the parcel of air, which is at 23 degrees, and the surrounding air, which is at 18 degrees. Okay, so step one is always take the difference in temperatures. So 23 minus 18 is equal to 5. Step two is the difference in rates. Again, the parcel of air is going to rise, so it goes down at the DAR, which is 1 degree per 100 meters. The surrounding air always goes down at the ELR, which is 0.65 degrees per 100 meters. So I'm just going to do my 1 minus 0.65, which equals 0.35 degrees for every 100 meters. And then step three is I'm going to take the answer from number 1, 5 degrees, and divide it by the difference in the rates, which was 0.35, and then multiply that times 100. And if I do that, 5 divided by 0.35, I'm going to get 1,429 meters. That represents how high the air will rise. Okay. So then I'm going to look on this side to see if clouds or where clouds will form. To do that, once again, I look at the parcel of air because as it rises, it's going to cool off, get more humid, and eventually hit its dew point. When it hits its dew point, that's when we'll get clouds. Okay, so step one, take the difference in temperatures, 23 and 5, and that is 18. Step two, the difference in rates. So again, the DAR, 1 degree per 100 meters, so 1 minus. And then the dew point goes down at the dew point depression, which is 0.2 degrees per 100 meters. So 1 minus 0.2 is equal to 0.8 degrees per 100 meters. And then step three, take my answer number 1, divide by that difference in the rates. Oops, 0.8, sorry. That is an 8, I promise. And then multiply by 100. So 18 divided by 0.8 is going to give me 2,250 meters. That's where clouds would form if the air could rise that high. But I can see that the air will never get that high, so clouds will not form. Okay?